No. All right, so we've been multiplying polynomials already. Now we're going to look at special formats. So this will give us a little extra practice in multiplying polynomials. It'll also help us to recognize some patterns that will give us some shortcuts. So the first one we're going to look at is the square of a binomial. Now you're often tempted to look at this and just square the 3x and square the 4. That is an incomplete product. Because what this actually means is 3x plus 4 times 3x plus 4. And so if you just squared the first and the last term, you'd actually be missing 2 terms, which are going to combine to be 1. They're going to be like terms. So we learned how to multiply these yesterday. We learned a distribution process where we would do 3x times each of the second 2 terms, and then 4 times each of the second 2 terms, right? And I briefly mentioned that that was often called foiling, okay, where you multiply the first. What's 3x times 3x? 9x squared. Yeah, because x times x is x squared. And then you multiply the outsides, 3x times 4. What do you get? 12x. Then you multiply the insides, 4 and 3x. What do you get? 12x. Then you multiply the last terms, 4 and 4, which gives you
16.
Now notice, I underlined each of these as I multiplied. And so each of them has 2 lines because the 3x got multiplied by 2 things. And the 4 got multiplied by 2 things. So everything got multiplied in somewhere twice. Okay? Then I add my like terms. What do I get?
9 squared plus 24x plus 16.
9x squared plus 24x plus 16. So if we just squared the first term and the last term, we would have got 9x squared plus 16. We would have missed that 24x, right? Now, I want you to notice how this final product relates to the 3x plus 4. 9x squared is the square of 3x, right? 16 is the square of 4. Okay, that's where they come from. The 24x is the 3x times the 4 times 2. Because notice we did 3x times 4 twice. And so we get 2 of those. And so that's like the shortcut. You can always FOIL this out and add like terms and get your answer. And that's great. You're allowed to do that. But a shortcut is to take and square the first term, square the last term, then multiply the 2 terms together and double them. That gives you all of the terms that you need. And it doesn't matter if you're adding or subtracting in there. If we'd had subtraction instead, we could have done the same thing. So let's look at one with subtraction. 5x minus 2y squared. So if I were to FOIL this out, I'd be doing 5x minus 2y times 5x minus 2y. So when I multiply my firsts, what's 5x times 5x? 25x squared. What's 5x for my outsides? What's 5x times negative 2y? Negative 10xy. So that's my first and my outside. And look, notice that my first term here has already got 2 tick marks. Okay, so I've multiplied that one twice. I'm done. Okay, these have each got 1, so they're going to get hit by another one. That means I got to multiply the negative 2y by each of those. So my inside is negative 2y times 5x. What do I get? Negative 10. Let's use xy. Okay, it technically doesn't matter because multiplication is commutative. But just to make it easier to recognize like terms, we put them in alphabetical order.
Okay.
Okay? And then we multiply our last. Negative 2y times negative 2y. 4y squared. So what do I get when I add my like terms? Negative 20 x, y. Everybody okay with that?
Would you have to switch the 4y though before the 20xy because it's
Nope.
higher degree?
No, actually they're the same degree because remember xy is second degree because it's 1 and 1. Right? The degree is the sum of all the exponents. So since that has an exponent of 1 and that has an exponent of 1, they add up to be a degree of 2. So that doesn't matter so much. We tend to leave it just like this. So like I said, this is a special product. So recognize that that 25x squared is 5x squared. Right? And the 4y squared is negative 2y squared. Right? And the negative 20xy comes from 5x and negative 2y times 2. And so 5x times negative 2y makes negative 10xy times 2 gives us negative 20xy. So again, kind of a special pattern. The only difference is we got a different sign right there than we did when we had plus. Everybody good with that? So we could shortcut these if I wanted to square 4x minus y. So what should my first term be?
Just
4x squared, which is 16x squared. Okay, I know my last term is negative y squared, which is no, negative y times negative y is positive y squared. And my middle term is the first term, 4x, times the second term, negative y, times 2. So what's 2 times 4x times negative y? What would, okay, think before you speak. Think it through.
X negative y.
Negative 4x
16x squared minus 8
2 times 4 is 8x
xy
minus 2
plus y squared.
Why are you shouldn't be using the distributive property. This is all one multiplication. Okay? 2 times 4x is 8x. 8x times negative y, negative 8xy. Okay? I only heard 16 come from you.
Negative 8xy. So negative 16.
Yeah. Okay? It's all multiplication. So you were trying to distribute that 2 to the 4x and then 2 to the y. That's not addition. Okay? That's multiplication. Okay? And there's only one y in that term, so there shouldn't be a y squared. There's only one x, there shouldn't be an x squared. Alright? Okay. So that's a shortcut, but like I said, if you have to write it out as the product of the two and FOIL it, then do it. The next pattern is a sum and difference pattern. This multiplies together to be what's called a difference of squares. So this is when you're multiplying together two binomials that look really similar, except for the middle sign. Let's make sure that we know that's a t. So, for instance, t plus 5 and t minus 5. What do I get when I multiply the first terms? T squared. How about the outside terms? Outside terms.
Wait.
This one times this one.
That'd be 5t.
Negative 5t. Inside terms.
5t.
5t. Last terms. Negative 25. What happens when I add my like terms? They cancel each other out. Negative 5t and positive 5t is just 0. So I'm left with t squared. Poor t. It's terrified of that negative 25. T squared minus 25. Follow? So notice what happened when we're multiplying a sum and a difference. T plus 5 and t minus 5. We get the first term squared, which is t squared, minus the second term squared. But that only happens when the first and second terms are identical, but one is plus and one is minus.
Will there ever be a plus in the equation?
If they were both plus, that's just like one of the examples we covered already. Like one of those.
The first one's minus the other one's.
That's fine. It doesn't matter as long as one's minus and one's plus, as long as they're opposite signs.
Okay.
If they're the same signs, we have one of these situations that we covered in the first examples. Okay? But when one's plus and one's minus, then those middle terms cancel each other out, and we get what's called a difference of squares, because we have a difference, which is subtraction, of two perfect squares, t squared and 25. So we could shortcut around that if I had something like 3x plus y times 3x minus y. So we need to recognize that we have two pairs of identical terms, 3x and y, and we have the sum of one and the difference of the other. So that means I should be looking at the difference of the two squares. What's 3x squared?
9x squared.
9x squared. And what about y squared? Y squared. So I have 9x squared minus y squared. Okay?
So you.
How should we do minus inside of the because it's a negative?
If you go back to this example, we had positive 5 times negative 5, which is negative 25. Okay, because it comes from the product of the last terms, which is always
So
negative.
you didn't have to do like the negative 5t plus the 5t.
I didn't do this middle step because I recognized the shortcut when I have two identical terms, but they're opposite. Okay, I could have used that middle step if I didn't recognize that or if I forgot, but when I add my like terms, I still would have got here. Okay, so this is a kind of a shortcut around. Now, here's where this comes in super handy. 26 times 34 is 884. You know how I know? Let's think about this. What's halfway between 26 and 34? 30. 26 is 30 minus 4. Right?
Yeah.
What's 34? 30 plus 4. I've got two identical terms. One's being added, one's being subtracted, right? So, I know that their product has to be the same as 30 squared minus 4 squared. That's my difference of squares pattern. That's just what I did in example 2 there. Right? What's 30 squared? 900. What's 4 squared?
16.
What's 900 minus 16?
884.
884.
That's cool.
So that's how I know that 26 times 34 is 884.
So like on the homework when they have these special products, you want us to do these steps.
Yep. So here's another example. How about 87 times 93? 87 times 93 is going to be 8,091. Right? We're not sure yet why. Let's see. What's halfway between them?
3.
Halfway between 87 and 93 is 90. And 87 is 90 minus 3. 93 is 90 plus 3. Right? You okay with that?
Yes.
All right. So that means their product has to be the same as 90 squared minus 3 squared. What? Yep, it's always minus when we're looking at the sum and the difference.
1,791.
What's that?
1,791.
Nope. Because you added 9 and 9, or multiplied 9 by 2. 90 times 90 is
8,100.
8,100.
So it's 8.
Minus
9.
9 gives us 8,091. Remember that 90 squared is the same as 9 squared times 10 times 10, or times 100. So that's how we get 8,100. Make sense? All right, let's do a biology problem.
What?
What? Biology? I don't like biology. I love math. Math's my favorite.
Math is my favorite.
Pedigrees.
Yeah. So, have you guys done Punnett squares in biology yet?
Yeah.
Oh, like a million.
You did last year. Okay. Well, the concept is really simple. Okay. And so they explain this here with border collies. The color of the dark patches of a border collie's coat is determined by a combination of 2 genes. An offspring inherits one patch color gene from each parent. Okay? Colors of their patches. Okay? Yes, it's determined by their genes. Not the genes that you wear, the genes that you're born with. Okay? So each parent has 2 color genes, and the offspring has an equal chance of inheriting either one. The gene capital B is for black patches, and the gene lowercase r is for red patches. Any gene combination with a capital B results in black patches because the capital B, the black, is dominant. That's why they use a capital letter. Okay, so if you have a capital B in there anywhere, it's going to be black patches. Okay, because that's the dominant gene. So, in other words, if this was for your hair color from your parents, and one of your parents was capital B, you would have black hair. Okay? But if you have parents who have black hair and you come out with red hair, okay, that means that one of them had that recessive gene for red hair. Now, recessive doesn't mean, bad. Red hair isn't bad per se, but it means that it's always canceled out by whatever else is in there. So if you have red hair, that means that you got both red hair genes. Okay? So that you got that recessive trait from both your parents. So we have these border collies here, and they both carry the dominant black color, but the recessive red color. So the Punnett square shows the possible gene combinations of the offspring and the resulting patch color. What percent of the possible gene combinations of the offspring result in black patches? Well, let's think about this. If they have a capital B, then they automatically have black patches, right? So looking at this Punnett square, how many of those squares are black? 3 out of 4. So that's 75%, right? And what's the percent of having red? 25%. Now, we can model this with a polynomial. So let's look at this as a polynomial. Let's look at this as daddy doggy and mommy doggy. Now, when a baby is formed, they get half their genes from the father, half their genes from the mother, right? And so basically, what happens is that DNA splits down the middle. So if the daddy doggy has capital B and lowercase r, then the pup has a 50% or 0.5 chance of getting the capital B and a 0.5% chance of getting the lowercase r. Notice that when you put that 50% chance with the 50% chance, you get a 100% chance. In other words, the dog has to get one of them. Okay?
Would it be... okay.
Now, it's the same from the mom in this case, because in this case, the mom has the same color genes as the dad. That's not always the case, right? That's not the case in humans. It's not the case in dogs. But in this example, it is. Everybody good so far with our setup? So what we do is we model by looking at the product here. Now this is a special product because they're identical. This is the same as 0.5b plus 0.5r squared. Okay. Now remember that our format was if I have two identical ones, like a plus b squared, I'm going to get a squared and b squared at the ends. And in the middle, I get 2 times the two terms. So in this case, at the beginning, I have 0.5b squared. And at the end, I have 0.5r squared. Right? What's in the middle? You don't need to multiply it out. Just tell me what parts I put in there. Yeah.
The 0.5b times the 0.5r.
Okay, you're missing one thing.
The squared. Oh,
Nope.
2.
2. 2 times those. Okay. So what is 0.5b squared?
0.25
0.25.
plus.
Nope.
Wait, no. 0.25b squared.
B squared. Now, since we're modeling biology, okay, instead of writing b squared, I'm going to write b. But only because it's a Punnett square problem. Okay. Normally, I'd write b squared.
Oh, because there's 2.
Because there's 2 b's. Yep. Then in the middle, what's 0.5b times 0.5r? 0.25br. Then times 2?
0.5.
0.5br. 0.5 times 0.5 is 0.25. Then times 2 gives us 0.5br. And what's 0.5r squared?
0.25r squared.
Right, and I'm going to write r. Okay? So which of those terms give the dog black patches?
The 25% and 50%.
Both of those, because whenever that capital B is in there, we get black patches because it's dominant. Okay, it ignores, it basically overrides the red patches. All right, so together that gives us the 75% chance. Now the difference between these two is that the dog with both capital B's will only have pups with black patches because it's always going to contribute a black gene and they're always going to pick up those black patches. Okay, the one with the B and the R might have some with black patches, might have some with red patches. Okay, but that's more information that you'll learn in biology class. All right, any questions? 9 questions. All right.